Another type of analysis available in GeoStudio is what I have called an accumulative plastic strain type of an analysis. I can best illustrate this by talking about a case history. It's called the Waba Dam case. This is a dam. It's a low dam with side berms on soft sediments. It's in the Niagara Falls region on the Canadian side of the Niagara Falls. And as you can see by the side berms and the very flat slopes, that this dam had a very high factor of safety under static conditions because of its very weak foundation. The foundation soils are clay soils, weak clay foundation soils. And the question was what would happen to this dam during an earthquake analysis. So as I've already said, the static factor of safety was very high because of the weak foundation. And if we do a Newmark type of an analysis, even with the dynamic stresses, the factor of safety never falls below 1. Therefore, we cannot use a Newmark type of analysis for permanent deformations in a case like this. The strengths of the clays do not change during any earthquake, but there can be some accumulative permanent plastic strains. So what we can do is we can use the quake results in sigma, and we can do an elastic plastic stress analysis in sigma for each time step and accumulate the plastic deformation. Conceptually, when we do an elastic plastic deformation analysis, then we might have some elastic deformation and then some plastic deformation. But during the earthquake analysis, we might get some reversal and we get some plastic deformation and then some more plastic deformation. And eventually, at the end of the shaking, there will be some accumulation of the plastic strain during the shaking. And that is what is being done here by taking the quake results into sigma for an elastic plastic deformation at each one of the time steps for which data is being stored. So here is the analysis tree for doing a Waba Dam type of analysis. The first step is to once again, using sigma in this particular case, to establish the in situ stress state in the ground. We always have to start from a known stress state. The second step in this particular case here is to do a elastic plastic stress redistribution in sigma. When we do an in situ analysis, we may land up with some overstressed regions. In this particular case, we need to get rid of and make sure that there are no overstressed regions before the shaking starts. Having done that, we have now established the stress state in the ground, and we can now do a quake analysis. In other words, a shaking analysis. In this particular case history, there were 2 earthquake records, a near field and a far field. So there are 2 different earthquake records being examined here. But having done the quake analysis now, we take the results into sigma, and once we have them in sigma, we can do elastic plastic stress redistribution analysis at each one of the time steps during the earthquake and accumulate the plastic strain. For illustrative purposes, the example also contains a Newmark analysis just to demonstrate that a Newmark analysis in this particular case would say that there is no permanent deformation. So then, once again, there were 2 earthquake records, and so we have two permanent displacements, computations, and two Newmark type of analyses. So here is the final picture of the result, and we can see here that there indeed was some accumulated plastic strain, some movement laterally, and then some heave beyond the berms. So this is what we call the final displacement field, and it's very graphic and helping us understand the permanent deformations at the end of the shaking. So what we can do then in sigma, we can plot the crest vertical displacement versus the y displacement versus time at the crest of the dam, and in this particular case we can see how the displacement has gone down, and we have accumulated, and ultimately we land up saying that somewheres it is possible that in this particular case that the crest of the dam would settle approximately a tenth of a meter during this earthquake here. The details of this type of analysis are given in the Waba Dam example we ship with the software. So if you are interested in more information about this case history, you can go to this example where there is a PDF document describing the analysis in more detail and gives you the steps that we followed in doing this type of an analysis. But for this brief introductory discussion here, the key issues are, number one, the number one issue is inertial forces. It was the mass times the acceleration that caused the soil to be overstressed and caused there to be plastic yielding. And the second issue is that it is the plastic yielding of the soil. The factor of safety never fell below 1, but in spite of that, the inertial forces, mass times acceleration, caused there to be some plastic straining and some plastic yielding of the clays, and this manifested itself in a possible permanent deformation if this structure were subject to this type of an earthquake. So that is a brief description of another type of analysis that is available in GeoStudio. Once again, it is applicable only to certain cases, but it is one of the options that is available.